Yes, sir. We start from here.
Can you make a bit bigger?
Wait. I think not here. Yeah, here.
Okay, we are done till 5 or 4.
Yes, sir.
Okay,
Sir, we went
read
done till
quickly.
4.
Okay, then read loudly, please.
The sodium 24 and 23 are two isotopes of sodium. Sodium 24 is a radioactive isotope that emits beta particle and gamma rays as it decays. The nuclide notation for the isotope sodium 24 is 24 by 11 sodium. Describe the composition and structure of neutral atom of sodium 24.
Okay, so what you wrote? There are two things. One is composition, another one is structure. So composition means what is available there in the sodium 24. So we have neutral atom. If it is neutral atom, then number of electrons and number of protons are same, right? Hello, Karim?
Oh,
Karim,
wait,
don't
sir. Yes,
mute.
sir.
Yeah.
I was talking actually and the mic was off.
Okay, you don't mute. That is better because our time we have to save. Look here, we have sodium 24, 11 protons. So neutral atom should have 11 electrons, right? This is first thing. Is it clear?
Sir, here I wrote it.
Yeah, very good. Then second information is we have 11 protons. Okay, which one directly we get from the notation that we have 11 protons. So there should be 11 electrons.
I also wrote the number of nucleons. Just
Yeah,
in
number of
case.
nucleons 24. Very good. And number of neutrons?
Here, sir.
13. Okay. So you got all the things. Very good. Then go to next.
Do I need to write that there is one electron at the outer shell because they said also the structure? And
Not
its electric
necessary.
configuration.
It's okay. It's okay. No problem. You have got all the information, necessary information. Okay.
What if it was of 4
Then go
marks or
next.
5 marks? Then how should I have wrote it?
They will never give you 4-5 marks.
Sir,
Maximum
I was
3.
just asking just in case.
Either 2 or 3. Okay. Then next, go to next. Make it more
State how the
specific.
composition of a nuclei.
Make it more specific. The answer you wrote, make it more specific.
How, sir?
How you are saying is number of neutrons, one more, like that. Number of neutrons, one more in sodium 24, this way. Make it more specific.
But sir, I am too much specific. Just neutrons. That's
Yeah,
all.
yeah. You write that specifically. Number of neutrons, one more in sodium 24. Quickly do it. Okay, B1 is correct. Yeah, B2 also correct.
Shall I read this one aloud?
Yes.
When alpha or beta particle leaves an atom, it leaves it in excited arrangement with more energy than normal. That excess energy is released as a photon of gamma radiation.
Okay. Actually, they are asking you only about gamma rays property. What is gamma ray? That's it. But how gamma ray is coming, they are not asking you that one. Is it clear to you?
Yes, sir.
They did not ask you how gamma rays come. They are only asking you what gamma rays are. So what is gamma ray? You have some properties of gamma ray, right?
Yes, sir.
Gamma rays are chargeless. This is one property. Gamma rays have the high penetrating power. This is another property. So this property should come here.
But sir,
And
these are
gamma rays are one of the
properties. Doesn't it mean that
yeah.
what
What
actually gamma ray is? Means what is it made up of, and how does it act?
yeah, they are asking you the properties only. Gamma rays are one of the electromagnetic waves. This one you write. Then you write gamma rays are chargeless. They have high penetrating power. These ideas you should bring here. Can you check with the mark scheme what the mark scheme says? Question number 5 we are going, right? Yes, look here. It is electromagnetic radiation rays, very high frequency energy, very short wavelength. This idea you should bring here. Only the properties. What gamma rays are. Okay, then next, quick. You write, you can write this in your copy, then you go there. So you understood it, Karim? Hello,
Yes, sir.
Karim. You wrote it. If you are not writing it, you will never write it. You will
Yes,
forget.
I was just writing this until we read the next
Yeah.
question. I would have told you.
Okay, okay. Write quickly.
Sir, you can check it. I will just resume the share and go to the mark scheme.
Okay, that one we'll discuss later. Let us finish it first. Ah, at the end, I will tell you what to do.
Yes, sir.
Mm-hmm. Okay, make it bigger. I can't see it.
Is this okay?
Yes, yes, now it's fine. Okay, so what you gave? Beam of beta particles going upwards. Why they are going upwards?
Sir,
Because
Fleming's
they
left-hand rule.
because they are positively charged, right?
Yes,
The
sir. Attraction and
yeah, the upper side is positively charged. That's why. And here you gave look, you gave here carving in a way it's returning back. The drawing should be not like that. It should go, upwards. It's not returning back. Do you understand what I'm saying?
yes, sir.
Your curve is going returning back. Why? It should not go returning back. It will go just bending, bending, and it's going upwards. That's it. Why you are
Sir, home sweet
returning
home.
back?
Sir, home sweet home.
This is this is one problem. Another problem is when
Sir,
it
like this.
enters. Yeah, don't carve so much inside. You just Next one is okay, and
Sir, this one was
and
highly energized.
yeah. Listen. There is another problem. Here you are entering the electric field till some till some path you are still straight line. Why?
Sir,
When
it
you
is
are
taking some
entering,
time to affect.
yeah, when you are entering the electric field, that time it will start bending. Is it clear?
But sir, isn't it like a parachutist is jumping and the air resistance is taking time to
No,
act?
no, it's not. It's not like that. It's attractive power. There is charge. You see, there is positive and negative charge. That's why it will uh, go from the electric field. It will curve starting. Is it clear? In some of the places there are 2 marks. So in that place you will lose 1 mark if you are
Like
starting
this.
later. Yes, yes, yes. From the beginning it will start carving. Okay, go to the next one. Next one, please, quickly.
Sir,
Yeah, I understand it. I understand it. You go next. There is only 1 mark. Next one,
yes, sir,
quick.
going to the next one.
Yeah. Okay. Draw the path of the gamma rays. Yes, you are drawn. You have drawn. Then 3. Explain why the path taken by the beta particles differs from that by the gamma rays. Okay, you understand it. What you wrote? What you wrote? Just I saw it. You just tell me what you wrote.
Yes, sir.
You're writing.
Beta particle
You read.
charge is negative. Oh, wait, it was over the page. Yeah. Beta particle charge
Hmm.
is negative and is attracted to positive charge, repelled from the negative charge by giving a dash sign over here, just to show this or
Hmm.
this as both are correct. Then,
Hmm.
while gamma ray has no charge, and is getting deflected and is not getting deflected light better.
Very good. Your answer is correct. Then last part. Read the question quick. Last part.
Yes, sir. Explain one reason why half-life 15-hour makes the isotope suitable for use in human body.
We got one MCQ question regarding this.
Yes, sir,
Can
I
you remember
remember.
that one? Yes. So you bring that idea and go to the mark scheme quickly. Check what is written there. Fast. Write that one.
Yes, sir.
If it is less time, then there is less ionizing power. Then it is less harmful for a human being. That's why. Go to the mark scheme.
Sir, it is here.
Mark scheme I don't see. Still your one. Your writing one. Now it's came.
Sir, it
So
was
you
slow
see.
internet.
Hmm. So you got it. Ionizing
So what should I
long.
write? Long enough to take measurements.
Here the or part you write. Or part you write. Right side one you write.
You mean by this one?
Yes. And beside it also you write it's less ionizing. Then it will be more understandable.
Sir, it is beta particle, right?
Beta or alpha, anything. If it has a charge, that's making it ionizing. Ionizing effect on our cells,
Sir, so what should I write?
on
Because
our body tissues.
if it has charge, then it might be alpha. So if it is alpha, then it is highly ionizable. If doesn't have, then it is
Both
gamma, which
alpha,
is
beta, they are charged. Both alpha and beta, they are charged. So they have ionizing power. Okay. This is one thing.
less ionizable or moderate ionizable.
What?
So what should I write? Yeah, less ionizable or moderate
Okay.
ionizable?
Listen, if it is working for, they are not talking about you less ionizing or more ionizing in respect to their power, but they are saying you about the time it's working, how much. If it is working for a long time, then this ionizing effect is working more on your body, right? So it is more harmful. If it is less half-life, then it is working for less time.
So
That
less
is the main thing.
ionizable.
The time. Yeah. So it is related to time.
Yes, sir.
Okay, go to your one.
Oh, yes, sir.
Yeah, question 5 is done.
Yes, sir. Question 5 is done.
So discuss the process of nuclear fission taking place in the sun. So what is the process? It's very faint. Can you read?
Okay, sir. Yes, sir. Uh, yes, sir. Two lighter atoms like hydrogen are moving here and there at an immense speed. They hit each other with great pressure, such small dis- uh, making some small distance between them, activate the, sir, what was that? I just forgot. Uh,
You wrote, you forgot.
activating the, no, sir, activating the, then I thought I would write, but I forgot what I need to write. Just a second, sir. Okay, this would be here. Sorry for the inconvenience.
So there is high density, high temperature required for nuclear fusion, right? Isn't it? This is most important thing. Then we need two hydrogen nuclei to fuse together to form helium. So can you see the mark scheme? The points came over there. You try to make your answer less descriptive, point wise, smaller points. You try to make them, and you are having here 3 marks. So write in 3 points, small points. Can you see the mark scheme?
Yes, sir.
So you
Energy
see
delivery.
what is written here. Joining together of small nuclei to make bigger nuclei, energy released, hydrogen used, or helium produced. So your this idea came over there. All this idea came over there. Hello.
Okay, sorry, sir. Here is fuse, which indicates joining, and here is energy. I also wrote release in the form of heat and light. Is it okay, sir?
Yes, yes, it is okay. It is okay. Fine. Then,
Sir, that's all.
so all these points came, right?
No, sir, just 2 points. Uh, over here,
Then,
this one didn't came.
then you wrote about the helium, hydrogen nuclei joined together to form helium. That one you wrote.
No, sir.
Here at the top, what you wrote? Two lighter.
Sir, will it be okay? This one, to fuse together to become a helium atom means activates the
You should
nuclear forces,
mention.
which I
You
forgot
should
to
mention
write.
hydrogen. Listen, you should mention hydrogen because they are talking about the sun,
Lighter
right?
atom like
So
hydrogen.
what is
Here,
you should
lighter
mention
atom like
hydrogen.
hydrogen.
Okay,
Sir,
okay,
here is hydrogen.
okay. Then it is fine. Then it is fine.
Right. There is this
Hydrogen to
one
helium.
thing,
This
and
one you
this
have to
is here.
mention.
That is nuclear forces. Activate the nuclear forces. Sir, so I will get full mark.
Huh?
Sir,
Yes, it is okay. It is okay. It is okay, but try to make it more, smaller, not so much description. In exam, you will not get that much time. Okay,
yes, sir.
Karim,
Yes, sir.
go to next one. Please.
Right below the steps of nuclear fusion in the sun in equation. Uh, see printed
Okay,
on
you got
page 18.
you got three equations. Anyone? You got three equations. You can. I also gave you notes, right? Writing notes are available. Yes, you
Yes,
did it.
sir.
Listen,
Yes, sir.
Karim, you cannot get it in that page mentioned because I edited later, but in the mark scheme it's not edited. That's why you will not get in that page. So let us see your writing,
Sir, even
what you
though
wrote.
here is only 17 pages, it was simple that I would
Yeah,
not get it.
yeah,
Yes,
because
sir,
it
like
was a big
this.
one. I made it smaller.
Oh, I forgot one
Okay,
thing.
so here your one.
Yeah, sir, okay.
Okay, okay, fine. But it will be better if you write the way I told you to write. In your copy, it's written the equation. Like you have to mention also the atomic number, not only the mass number, also the atomic number. Huh?
Sir, here it is.
I
H2,
gave you,
H3,
yeah, write in,
atomic number.
write in, yeah, write in nuclide notation. That one is better.
Okay, sir.
So you write here only one thing, that write in nuclide notation.
Okay, sir.
Okay, next one, please. Explain the main difference of nuclear fission and fusion with examples. 3 marks.
Yes, sir.
So you go to the mark scheme first. Then you check with your writing. All this point came or not. You identify. Then we can go faster. Okay, so it's not there. Then we can now do by ourselves. Go there.
Yes, sir.
Go there. Your one. So what you wrote? Can you read?
Yes, sir. I wrote Fusion is the joining of light atoms. In bracket, I wrote, how do I, okay, this will help. Over here, I wrote, what was that? Atom, oh, like. Uh, I forgot to give the K and I put an T1 over here, but it was like hydrogen atom to form heavier atom and give off energy and the neutron, while fusion is the process where heavier atom, I
Fission,
should,
fission,
yes sir,
fission.
okay. Fusion is the joining of lighter atom like hydrogen atom to form heavier atom and give off energy and the neutron. Sir, I wrote one neutron, means just to
It is
specify.
not, listen, it is not always necessary to have a neutron extra. It depends, okay? So you just stop there. Uh, two or more lighter nuclei join together to form a heavier nucleus. That is done. Is it clear?
Yes, sir.
Then you can bring the example. Later on, you can give the example. In your example, it might come that there might be one neutron extra, or there were three ways I showed you the nuclear fusion, right? Equation.
Yes, sir.
So anyone you can write. Anyone you can write. Now fission is opposite of fusion. There we are having the splitting, right? We are having and okay.
Fission is the
Another thing
process
you
where heavier atoms split apart due to a force of a neutron in it and creating instability. It breaks down to a relatively lighter, means relatively to fusion, means just to say relatively to explain that it is, sorry,
okay?
sir.
So this is one thing.
I think you can understand what I meant by relatively
Now
means.
in
Relatively lighter atom giving off energy and neutron to create a chain reaction.
relatively means
Okay,
yeah,
relatively
relatively
means, let me
lighter
explain,
means
sir. Okay, here
yeah,
relatively,
relatively means
okay, sir, let me explain.
relatively means if you
Relatively,
come
uh, I am trying to say that if we have 23, uh, no, 299, just for example, by something uh, of an uranium, just to, because I can just do much more bigger, okay, uranium. So what I meant by relatively was like it would be one atom, like atom A plus
it is
atom
okay,
B.
I understood.
Okay, sir.
Karim, I understood it. No problem. Now you understood that one also. I can uh, I can understand that you also understood it now. Now what we have to do? You bring the examples. What you did not do, that is bringing the examples. Like in your example, you can bring the idea of
Like which I did
fusion
here.
is happening in the sun. Fusion is
Like
happening in
which
the
I did
sun
here.
and stars, right?
Yes,
You
sir.
wrote it. And nuclear fission is happening where?
In
In
the nuclear
the
reactor.
power station. Yes,
Yes, sir,
reactor or
nuclear
power
reactor.
station. Okay, so these ideas you should bring here. That's it. Okay, done. Go to the next.
Yes, sir. Oh, wait a second.
You take the notes here that you bring the examples. Right here that you should bring the examples.
Yes, sir.
Okay, go to the next.
Yes, sir. Plutonium is a radioactive
Again,
isotope.
okay, wait. This one you do not need to read. This one is the same as the question we got before. Okay, so same idea. You have to bring the structure and composition like before. Is it clear?
Yes, sir. So do you need to see that what I did? Okay, let me read it aloud. It has 238 nucleon, from which 94 are proton, 144 are neutron. Then after a full stop, means here is the full stop, it has 94 electrons to cancel the charge of proton.
Okay, correct. You are correct. Can you check now the mark scheme? How the mark scheme expects?
So as I said in the last time that it also expects the electric configuration and which belongs to where.
Yeah, you you see they are saying all protons and neutrons in the nucleus and electrons orbit the nucleus. That's it. You can bring this idea. So you write this only there. Electrons orbit the nucleus or protons and neutrons stay in nucleus. So are you writing?
Sir, like I said here, that it has 238 nucleons. From the idea of nucleons, we can say that it is a part, means this is what makes the nucleus, means part of nucleus. I wrote from which, so the proton and neutron are staying
Yes,
in the
your idea is correct, but they want it more specific. Huh? In the mark scheme, the way they wrote, they want it to be more specific, to write clearly that protons and neutrons are staying in the nucleus, or electrons orbit the nucleus. That's it. So just take this note here. Huh? Your paper, you just take the notes. That will help you to remember later quickly.
Yes, sir.
Yes. So here was one technical, error with grammar. Can you read the question that state how the ionizing effect of beta particles compares with the ionizing effect of alpha
Yes, sir. I
particles?
also
So
did it
it
the
will
last
be,
time.
yeah, this is weaker, okay, weaker.
It will just be reversed like this.
Yes, it's the understanding of grammar. That's it. Okay, then next question number 8.
Yes, sir.
Question number 8, please, quickly.
Sir, are we done with
So
questions or like
we are very close, huh?
Yes,
We are
sir.
very close, close to the win, right?
Yes, sir. We would be needing it later on. Okay, state two
So
atomic
just
figure.
check from the mark scheme. Hey,
Yes,
check
sir.
from the mark scheme, then it will go fast.
Yes,
Hmm.
sir.
3 and 4,
Let me
3
say
and
I do
5,
check.
3 and 4. Check.
3 and 4, 3 and 5,
Hmm.
3 and 4. Yeah.
Okay,
Then it
correct.
is
Then
17 and
next.
35.
Correct. Then next.
Yes, sir. Correct, 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 correct.
Yes.
Yes, sir. Now we are here.
Yeah, it is a nice question. Suggest two major sources of background radiation. You don't know. How come?
Yes, sir. Actually, I missed it. Uh,
Why?
nah, sir. I
Background
don't know
radiation
how I missed
sources,
it, but I
example
missed
you
it.
wrote. You wrote in your notes.
Medical diagnosis.
You check your notes. You wrote. I told you to write.
Natural phenomena.
Hmm?
Sir, I wrote, what I wrote is, okay, go one. I wrote is one is medical diagnosis and another is natural phenomena.
No, background radiation sources.
Yes, sir. One is medical diagnosis, which is man-made resources, means man-made sources, because for
Medical what? Medical.
diagnosis instrument.
Okay. Then another one.
Another one is natural phenomena.
Don't say this way. You say very much specific. We clearly mentioned, we gave clearly the examples. You wrote in your copy. Where is your that copy?
Sir, not in the reach
Huh?
of my hand.
So you should have it close to you. And while you are mentioning the sources, you should go with major sources. Okay. Your major sources, cosmic rays, major sources, radon gas, and major sources, nuclear power station, right? Nuclear waste. So when you are mentioning, first mention these three. If you want to use more, then
Sir,
next
can I
time you
just
come for
say
medical.
cosmic ray?
Yeah, cosmic rays, radon
No,
gas,
sir, just cosmic ray.
then yeah, cosmic rays. This is one. Radon gas second. Then we have nuclear waste from power station. Is it clear?
Yes, sir.
So easy thing you couldn't answer. It is really disappointing for
Sir,
us.
I answered the last time. I just missed this one
Okay,
anyway.
go back,
Yes,
go
sir.
back quickly.
Means to my answer sheet.
Hmm. So you check out whatever you gave, these are matching or not with the mark scheme. You wrote 22.
Yes,
Can
sir.
you
I wrote
check?
22, 28, and 80.
22 you gave, that is correct. What about next one?
Sir, next one was 28.
How you got 28?
Sir, background radiation was,
Check.
sir, background was 22 and initial
Go to the
count was,
graph. Go to the graph.
yes, sir.
Hey, go to the graph. At the
Yes,
beginning,
sir.
what is the reading?
Sir, it is 50. Here it is.
How 50?
Sir, it is
How it
given
is
here.
50? It is not 50. No, it's below 50. Check.
Yes, sir, 49.
It's 49. It's clearly shown 49. So 49 minus 22, how much it is?
27, sir.
So correct it, 27, quickly.
Yes, sir, did it.
So if you are correcting it, then next one will also be corrected. Do them correctly. And let me have the values.
13.5, 22 plus.
Karim, got the answer?
Not yet, sir.
Look, your one silly mistake made us slower. You should be more careful.
Yes, sir, 85.
So check out in the mark scheme. Is it 85 or not?
Sir, it says 85 to 90. He's
So it
taking,
is correct. Then next. And you
yes,
are
sir.
showing the working also, right?
Yes, sir.
Next. D.
A student suggests a change to the experiment in C. He suggests completely increasing the radiation detector in lead before, what? Okay, I should read it from here, like this. Okay, encasing. Encasing the radiation detector in lead before the sample that emits beta particle is placed near to it. The effect of the count rate background radiation may then be ignored. Describe and explain the effect on the background count rate recorded by the detector of completely encasing the radiation detector in lead. I didn't understand, so I didn't write it.
Very good. So it's encased in a lead, right? Lead box.
Yes, sir. It was suggested.
Hmm. Suggested by one student, right?
Yes, sir. I don't know why. Because
Radiation detector
it
is
is,
in lead. So if it is in lead, then beta particles will be stopped, right?
yes, sir. Not only beta particle, none of the,
So if it is okay, so if the beta particles, if there is lead encasing or lead box over there, then will it be able to detect any beta particles?
no, sir.
So if it is so that it cannot detect beta particles, then what will happen? Describe and explain the effect on the background count rate recorded by the detector and completely escaping the radiation degrees. Now, uh, from background radiation, you are getting. They did not mention what type of radiation you are getting from the background. From background, you might get alpha, beta, gamma, all right,
Yes, sir.
isn't it? So if it is encased, then encased in lead, then alpha beta will be stopped from background radiation. But if there is gamma in background radiation, that cannot be stopped
Sir, they didn't
completely by
mention the
lead.
length. So it can also be that the box of the lead is too thick for gamma to pass. They didn't
So
mention the,
as they did not, yeah, as they did not mention anything, that's why we can like assume that we can guess that there is some gamma or there might be some gamma which might enter and the detector can get the count from there, right?
yes, sir.
So what is happening that uh, the detector will get only few counts, right? Or detector will
Because
show only few counts because of the gamma from
because
background
most of the
sources.
gamma rays are being stopped.
Yeah.
Not all, most.
We can say in reverse way, we can say
Sir, sir, sir.
isn't it? Hello?
Sir, just for a second, I can't hear a word you say. Not even a single word.
Yes, it's because a direct call came.
Oh,
Because a direct call came, that's why. So what I said
sir, may I
that
take 1 minute because
there
I
will
need to go to
be
washroom.
sure, sure.
Thank you, sir. Yes, sir, I'm back.
Yes, very good. So what I was saying that from background radiation, you are saying in one way that there will be, you know, gamma radiation, and that is mostly stopped by the lead, right? Lead box or lead, protector. So lead encasing. In reverse way, we can say a few of the gamma radiation can go through the lead encasing. Is it clear?
Yes, sir.
I prefer, this one, that a few of the gamma radiation can enter the encasing, and it can be detected by the detector. Is it clear now?
Sir, this one,
Hello?
that some gamma ray in the background count.
Yes, yes. Okay. So it is clear to you, right?
Yes, sir. So,
The first thing you
what
have
should
to
I write
write,
actually?
background count will be reduced. These 2 points. The first point they wrote, background count rate is reduced. Then the one you underlined. Have you got it?
Going there, sir.
You write there. Write in your copy quickly. Write in your worksheet.
Yes, sir. Sir,
Next.
yes, sir. We are already
Next
next.
one. State and explain. দেখো, state and explain whether the student's suggestion is sensible one. What do you think? It is sensible?
No,
No.
sir.
Can you read what you wrote?
Yes, sir. No, because background radiation
Hmm.
count is not only due to the source, it is coming from nature or man-made material in environment which is being counted. I think this should not be the answer. The answer should be something like
Your
this
no
because,
is fine, but the explanation is not correct.
yes,
Your
sir.
no is okay, but
Because
after
when
no,
when
what
we
you
need to
wrote, that
count the
is,
source means when we need to count the rate of source means it is emitting, we need to take the counter outside the lead box. So on that time we need the means background count to detect the correct number.
yes, now your answer is sensible. But the one you wrote, that one is not sensible. Am I right?
Yes, sir.
Okay, then check in the marks what's written
Okay, sir.
and
Not
you write your
sensible,
answer
all better
again.
radiation would be absorbed or not, or no better radiation reaches the detector. Sir, should I write it in my way?
Okay.
Uh,
Yes, your one is also like same.
okay. Sir, is it okay?
Uh-huh. Correct. Your answer is okay,
কিন্তু
but
স্যার
it
এটা
is
তো অনেক
too big.
লম্বা।
Yes, it is too big.
So
Make
what
it
should I do?
smaller. Only till before end. Till before end, it is fine.
And
Yeah,
which
you
and?
wrote and when. Before that, what you wrote, that is also enough.
Sir, I
Okay,
can't see.
to
Can you
get
just
the
tell
2
me where?
marks. And you wrote and when after detector, after reach the detector.
Which one, sir? Can you
Yeah,
just annotate?
yeah, and when you wrote.
And you
You
talking
got it?
about this? Oh yes, sir. I saw.
Yeah. Okay, before that, whatever you wrote is fine. Is it clear?
Yes, sir.
Then next, go
Okay,
fast.
sir. Then just okay. I will let look at from the. Yes, sir.
Hmm.
Sir, we did it? Okay, we did.
Yeah, this is the last one.
Yes, sir.
So the first one already we understood. We are not going to discuss that one anymore. The next one, B1. Can you show your writing, B1?
Yes, sir.
Can you read it?
Yes, sir. It contains 209 nucleon, of which 82 is proton and 127 is neutron. It contains 82
Okay,
electrons to
not
cancel
that
the charge
one.
of proton.
B1, B1. B1, that one already we understood. We
Oh,
discussed
okay,
three
sir.
times.
It will
Now B1,
contain
what you wrote?
it will contain one more proton, but the neutron number will be same as before. Sorry, sir, nucleon.
Okay, correct, correct. Correct,
Nucleon,
next,
sir.
next.
Oh, okay, sir. I just thought you are.
Nucleon numbers or neutron number, same thing. Go next. It will nucleon number or mass number, okay?
Okay, sir.
Then next. Least least strongly ionizing, most strongly ionizing. Okay, correct. Next. Yeah, 3. Part 3. Go to part 3. Where are you?
What happened?
Your screen still
Okay,
on.
okay.
Okay, go next. 3. Part 3.
There is some problems, sir. Is it okay
Show
now?
me the diagram. Go up. Yeah. Magnetic field out of the page.
Sir, can you see?
Okay. Yeah, it's going upwards. So you already understood the idea, like
Yes, sir.
how you have to correct it. We are
Yes, sir,
not
I will.
discussing it anymore. You will correct it.
Okay, sir,
The
just let me
same way.
give it a
Next,
big
go to
reminder
next.
to me.
Yeah.
Let me just give me a.
Correct it. Just you write that correct it. Then next. Go to next.
Sir, sir, how many questions would be there in the question paper?
2 or 3 structured questions only.
Okay, sir, how many subparts? Because till 9:30 I would be busy because I have another class.
I already told you it will take not more than 40 minutes. It is 30 minutes exam. 10 minutes you need for, technical issues. That's it.
Okay, sir.
So you can take it.
Sir, I can
Then
just type it in the computer and give you. Is it okay?
no, in Google Classroom. G class, in Google
Comments
Form I will
like
give
the
you. Google
MCQ.
Form.
It would be like the
Yes,
MCQ.
Google Form.
Okay, sir.
Yes. Not MCQ, it is structured, but in Google
I just
Form.
need to type it
You
in
have
the
to
space
write the
given
answer.
below.
Yes. Short answer.
Yes, sir.
Okay, then only one question you have to draw and scan and upload the diagram. Okay.
Okay, sir. Then what would I
Take
do?
the
Sir, can I just do it like in the computer because the scanner is not. So I will just do it in the computer, give you an SS so that it won't move anymore.
no problem, no problem.
Okay,
It's
sir.
okay.
So is it?
You can have the screenshot. You can draw on computer and have a screenshot. Then you can give, no problem. Same thing.
Okay, sir.
Yeah, continue.
Yes, sir. End of worksheet. Not yet.
Yeah, check with the mark scheme all this quickly.
It shows 35.
So you did wrong.
Yes, sir. Two separate sources. Yes, sir. Like here, I gave medical
Show me the
diagnosis.
main question. Show me the main question.
Here it is, sir.
Yeah. Yeah, go down. Yeah, can you read it?
Yes, sir. The average reading for the background count measured by the technician is 16 count per minute. He then brings a sample that contains a radioactive isotope of lead close to the detector, and he finds that the new count rate is 92 per minute. The half-life of this isotope is 3.3 hours. Determine the count rate measure using the detector after 6.6 hours.
Okay. 6.6 hours means 2 half-lives, right?
Yes, sir. And I did too. First,
So,
I subtracted 92.
yeah,
Subtracted.
19, hey, 19 plus 16, 19 plus 16,
Why
that will
19,
be
sir?
35.
Sir?
19 plus 16, because the
Okay.
count rate will also have the background count added.
Oh, they said.
So add it, 19 plus 16, 35. So done, right?
Yes, sir.
The worksheet is done. So you give me the corrected worksheet tomorrow or Friday.
Okay, sir.
Karim?
Yes, sir, I can hear you.
Yeah, you can give me it on tomorrow or Friday, the corrected worksheet.
Sir, I will give you. Sir, it would take some time, sir. I will give you till Sunday.
Sunday?
Yes, sir.
Sunday will be so late, right?
Sir.
Try to give on Saturday.
Okay, sir, I will try.
Okay. So I'm giving you the uh, script within minutes, huh? Just wait, huh? We are ending the class.
Sir, just a minute.
Yeah, rest of the discussion we'll do in Messenger.
No, sir, I'm just writing it so that later on I don't forget that. Why was the reason?
It's fine. It's okay. You understood it. That's it. Okay.
Yes, sir.
Done?
Done, sir.